Desertification is formed in areas where trade winds are offshore, and from time to time these winds dey blow across the sea or dey blow towards the sea, leaving the land desertificated and being baited by cold current. Dey result in a kind of erosion where wind is most potent. Increase in temperature and the erratic rainfall result in the high amount of wind that blows across the desert and tends to erratically abrase or tend to price apart particles of rock by sculpting them into different forms. Sometimes the alternate wetting and drying also result in exfoliation where the various layers of the rocks will now be peeling out and prising apart to form screeds. When wind erosion is armed with other factors of weathering, the sculpting tend to be high in the desert. Some mechanisms of erosion that affect the rocks are these. One, we have wind abrasion, which tend to take place with siltation, suspension and other surface creeping of loose materials to form either depositional landforms or erosional landforms. But most of the landforms that are formed by wind abrasion itself are mostly erosional. Wind abrasion is when the wind is armed with pebbles and other shingles that has been following the wind. It uses it to abrase or scrape the surface or lower surface or upper surface of the rocks, making them to form different irregular shapes or gore of different kinds. Wind abrasion tend to polish and warm back areas of the rocks that are weak or areas of the rock that are in soft strata. Abrasion is not only confined to the desert, it also takes place in glacier and other areas. Two, we have wind deflation. Wind deflation is when loose materials or loose particles of the soil, sand or pebbles are being blown into the air and the open ground is being excavated, or the layer of the earth, the lithosphere, is blown into the air, making that place to be depressed or a hollow to result that is called either a dust bowl or deflated hollow. After a time, that place will now form a swamp or oasis when the torrential downpour that is erratic in the desert tend to bring rainfall that now flows into those places and cover them up. Three, we have what we call wind attrition. Wind attrition is when particles in the air, rocks or pebbles in the air, they tend to scrape or collide with one another and wear one another out in size, reducing one another in shape to form small layers of rock or fine-grained soil or sand. Landforms of wind erosion, we have what we call rock pedestal or mushroom rock. These are gores that are formed from rocks in the desert. When wind abrasion now lower their base or their lower side to form a grustic gore with irregular shape, having grooves, hollows, cuts on the surface in areas that are soft rocks. The upper rock or the upper part of the rock, if it is hard rock and the lower side is soft rock, this alternate band of soft and hard rock will highly be affected by wind abrasion in the desert to form mushroom rock or rock pedestal. This rock pedestal is mainly resulting from wind blasting and wind abrasion. When airborne particles now scrape and cut rocks in their soft areas to alternate grooves and hollow to form grustic looking gore. We also have zoogens. Zoogens are weird looking furrows and ridges that has been dug or wind has sculpted in a layer of alternate and soft band of rock, where the alternate soft and rough band they are in horizontal strata and the one that is very resistant is below. while the ones that are not too resistant are above. When wind comes in contact with the rock, it will form a furrow or ridges across the rock. There will now be vertical shape of cut out furrows at the various forms of the rock band that will now result in something like corridors across the rock surface. So they are mainly of 3 meters to 30 meters, or from 10 feet to 100 feet. So these furrows, they tend to lower and widen by continuous wind erosion. We also have yandans. Yandans are similar to Zoogens, but they are alternate soft and hard rocks that are in vertical layers. They are standing blocks of rocks where some parts are weak and some parts are resistant. So the resistant part will resist the wind abrasion, while the soft part will give way to wind abrasion. Wind abrasion will now form a long, narrow corridors on the soft band of rock in the directions of the prevailing wind. So that place will now look like an eye that can easily be passed, separated from the hard rock bands. The lower part will now form a furrow, while the resistant rock will now form a ridge, standing block on the platform. Where we can find examples of these rocks, we have them in Atacama Desert. Ventifats are multifaceted pebbles or rocks that have been polished by wind abrasion, where their sharp edge or their edges are on the side of the eddies, while the other side that is windward is smoothing in the direction of the prevailing wind, and it rises towards the eddies, making it to now be having many shapes and grooves. We also have drain cutters. Drain cutters are three-faceted pebbles or stones that has been polished into three faces by wind, where the eddies is having the edges and the other part is smoothing in the direction of the prevailing wind by wind abrasion. We have deflated hollows. Like we said before, deflation is when wind tend to remove the upper surface of loose clay, sleet, and sand from the desert, blowing them into the air and making that place to now form a hole. Examples of rocks that have sodium chloride or sodium carbonate can easily be evaporated into the air when they have water coming in contact with that place, apart from wind. Also, we said these hollows can easily become oases at the end when wind give way to water or torrential downpour. These areas are easily inhabited by man or highly used for cultivation of crops in the desert. Example is El Kafra in Libya. Depression basins, gullies, and alluvial fans can also be formed after the wind has abrased certain parts of the rock. When water now comes during rainy season, water will now tend to produce these landforms in association with mica and bots. When these mica are worn by prolonged erosion after a continuous erosion for a long time, it will now form an eroded lower shaped dome or flat top hills that are called bots. Let's now look at landforms that are formed from wind deposition. Wind deposition may result in sand dunes, but we have sand dunes of different types. We have those that change form and are live. The live means they move from one end of the desert to another. We refer to them as live dune or moving dunes. We also have benchants or crescentic dunes. Benchants and crescentic dunes are moon-shaped crescentic dunes that are formed from the advancement of dunes when sand are against an obstacle in the desert. So the prevailing wind will now smoothen one side of the sand or the accumulation of sand against the obstacle to be gentle sloping. So on the other side, where you have the obstacle, the convex sloping side will now form two horns of about 15 to 30 meters on the side of the edges. Longitudinal or self dunes are sword-like dunes that are long and narrow like ridges of 100 kilometers long, and they are extended to like 10 meters or 30 meters high in the direction of the prevailing wind. The obstacles that form them or the corridor that they form are parallel to the prevailing wind, forming corridors that are now being further scarated by winds to form a kind of open path that the wind can pass. So they are standing blocks of sand or dunes that are long in the desert. When you look at them from a very high altitude, or you look at them from a far distance in aerial view, the top view tend to produce a long wavy sheet of different dunes that are curved in the desert in their different forms. So we refer to that extensive view as ripples. Other wind depositional landforms that we have are leos. Leos are aeoline materials that are blown because of their frailty or because of their fine dust materials to a very far distance, and they are deposited in that part. Where they are excavated and where they are deposited are far apart. They are also very good for